I've got a pretty neat update for you guys. We get the fuel system up and going. The Gen 5 with the LT1 pump. So we'll go over here. Right now it's in test mode, but we get the fuel pressure control module. It's been working for a while, but now I have it running the fuel pump directly. I'm getting ready to jump the ignition wire to my power steering to make the electric pump turn on for the steering system. Reflash the ECU back to stock. So here's my Boyd's welding fuel tank. I got the carbureted model, which was still kind of a mistake. Next time I do this, I'll talk to them, and basically these come with a bunch of baffling inside. Kind of see the indentations. Well, if I didn't have any baffling, I could have just dropped the pump in with the fuel level sender and everything, but because of all the baffling, is really hard to install that pump because all that baffling is welded, and so I had to just make it work. But what I did, took a LT1 fuel pump I got off eBay for like 50 bucks. Came with the top cover, but I have the part number for all this stuff. And we welded a few tabs, I think 4, and put studs in them, and then just cranked it down. This is a really easy way to do it. I'm not an engineer with this stuff, so just did it very simplistic. We pressure tested it, made sure we don't have any leaks. And that's one of the reasons I have this in the back of the bed. I still want to test it, and I'm going to run 2 fuel systems to show the difference. Standard LS style fuel system, which I've been running for a while, versus the LT1 Gen 5 system. So here's my main fuel connection. It goes to a low pressure fuel sensor. It needs to be set straight up and down, but I gotta just move it. But I just tested it. The pressure is very stable, so that's a good sign that it probably doesn't matter. So this runs to my harness. Here's the wiring for the fuel pump. It's basically plug and play if you guys need that with your wiring harnesses. I do, so that's no problem. I just ran it through here and underneath it. Again, it's just test mode. And I have the fuel line basically going straight to the intake mouth, to the intake fuel rail. So it's just a one connection, super easy. The reason I reflashed the computer is it's pretty neat. On the fuel pressure side of things, or I guess I should say the fuel pump, there's a lot of stuff you can do. This is HP tuners, and I had to adjust a few things. But let's say you need more pressure. This is just like tuning your VE table. You can request more pressure through RPMs and how much airflow it senses in the mass airflow sensor. So super neat. You have a ton of control here. And you can even see here, normal fuel pressure is 390 kPa. I'm not sure what that translates to in PSI, but I had everything set to basically 57 pounds of pressure, just to see if it get rid of some DTC codes that I left enabled. I think I can go to unit conversion. See, there's a kPa in this. Yeah. Type in, was it 390? Okay, 390 is 57 pounds of pressure basically. Well, that's odd. I want to fix that. Oh, it just now updated. Okay, so you can see right here the different fuel pressures. Normal is 320 kPa. That's what I'm used to seeing. So go back to here, go to unit conversion. What did I say? 320. That's 46 pounds of pressure, and that's what this system normally operates at. If you're at light throttle or idling, it's only 46 pounds of pressure. So it's taking it easy on the fuel pump, and it reduces the flow, but it gives the fuel pump probably a lot more life. Now once you get on it, this thing will go in up to, what does it say, 500 kPa. That's 72% 8.5 pounds of pressure. So that's pretty neat. You have a wide range of pressures to play with here. So these numbers can be changed here to get more or less pressure, and then you can mess with some things here. So pretty cool. So I have it all wired up, getting ready to test it. I have about 4 gallons of fuel in it. I need to set up my scanner so I can show and log the fuel pressure. But I'm hoping to find out with this if it makes any difference at wide open throttle, because I don't think it will. I'm using a stock system at 57 pounds of pressure, and I don't lose any pressure wide open throttle. So as long as I'm not losing pressure, I should be fine. But I want to use this setup anyways, because I think it will have a much longer life, and it's the OEM pump. So I'll test it and we'll see what happens. Alright, I'm pulling the road and get on it out here. Everything went fine. Had to get on easy, it'll just spin the tires. Try it again. It didn't feel any stronger, it felt the same. I am logging a horsepower PID that's pretty accurate, especially if you make changes, the number goes up or down. You are either making more power or you're making less power. It might not be making that exact number, but it will show power gained and power lost. So I'll compare this with what I had with the standard LS fuel system, compare the two and see if there's any difference. It didn't feel any stronger, it felt exactly the same. See what's going on with it. So when I get it home, I only have 4 gallons of fuel in it. I got things zip tied. I got hot exhaust. So, because this is all in test mode. And over the weekend, I'll mount the fuel tank, and I do a little bit of cutting. I cut an opening in the bed for the fuel door. Put that in. The fuel line is super easy to run. It is neat seeing the fuel pressure change with power. So most of the time it's like 47 pounds of pressure. So it runs 10 pounds less than LS. Now I'm going to, right here the graph, you can see the RPMs increase. I think I've been seeing up to 360 to 370 on the horsepower PID. Let's see what happened here. So you see right here we're running 60, it's making 64 pounds of pressure. It's requesting 73, so it's getting there. Here you can see the pressure change. I'm looking right at this area right here. So putting around, we're at, like I said, around 45 pounds of pressure. Then I go, let's see, wide open throttle. Actually, I kind of got it nice and easy here. And now we're at wide open throttle. It's fuel pressure request is only at 46, but next couple frames it changes to 73 pounds. So it immediately catches up there. Well, that's pretty neat. If you look over here, you see it says high flow. So it knows it's at wide open throttle and it's commanding the high flow settings. Instantaneous fuel flow estimate, almost 200 pounds per hour. I don't know if that's a lot or if that's good. I don't really know there. But I know this fuel pump is good for at least 450 horsepower on the LT1s. Alright, then we're back to kind of cruising. It's back to a normal state. Back to 46 pounds of pressure. Here's another. This run I kind of floored it pretty quickly. I floored it quickly and the pressure jumps up pretty quick. See right there, 70 pounds of pressure. Moving along, hit about 78. Here's my horsepower PID right there. This doesn't mean it's making 324. It could be making a lot more, a lot less. It's just a number. When I tune, I just try to increase this number from whatever the baseline is until I can't get any more out of it. And that works to me just as well as dyno testing. Dyno testing will give you a real accurate number of what you actually made, but this will get the same functionality in tuning. I can get the most power out of whatever I'm using. But that's pretty interesting. It's neat that you can see where it says high flow, you can see your pressures. Especially when doing these swaps, you really need to know your low fuel pressure, because usually if you have any hiccups in your engine swap, you have a loss of power or you get hiccups and things like that. The first place I like to look is fuel pressure. And right here, with having a low pressure sensor, you can monitor it at all times. The other tank in this, the stock tank that I put a fuel pump in, I was doing some testing and it started falling on its face, and I looked at my pressure, and sure enough, the fuel pressure dropped to 30 pounds, 20 pounds of pressure, and I knew I didn't have enough fuel in my tank, because I have a pump just kind of hanging out in the middle of the tank. There's no baffling, there's nothing, so I have to keep it over halfway full. So I go to the gas station, fill the tank up, play with it some more, and it holds its pressure at 57 pounds. But I immediately knew what was going on, where if I'm tuning someone else's vehicle and I can't see fuel pressure, something like that could be really frustrating, because I might just make a change, go and drive it, and then it falls on its face. I'm like, crap, what? I have to redo what I just did, and then it still doesn't. I have to go back and find out, put a fuel pressure gauge on it, and do a lot of things where this just helps a lot. It's nice to be able to see all that. So basically, to sum this up, what I've learned is I believe it does not matter if you use the variable fuel pumps in the LT swap. My truck functions exactly the same, but you get more functionality and dependability out of the correct fuel system for an LT. So if you can, the only hard part about doing a fuel system for LT is just mounting the pump into your tank. So if you can get an aluminum fuel tank or fuel cell for your vehicle, do anything you can to drop it in, you'll be fine. The rest of it's cake. Like I said, I'll include the low pressure fuel sensor. Even if you need some fuel line, let me know. I can pre-make all that, so you can just pretty much plug and play your fuel system. I'll show you on my fuel tank. I got lucky, but a lot of people won't. So you can see the height of my fuel pump. That sticks up pretty high. Normally that would not work out well, because your top of your fuel tank smashed up against the bottom of your trunk. Well, this isn't a truck, so it's bolted up to the frame, and I have just enough space where this does not hit the bed of my truck. So what you'd have to do, I'm sure Rick's tanks or something like that, they could just cut an indentation in this area and drop this whole top down about 4 inches, and that will keep this level with the top of your tank, and it won't hit your floor. What's nice, this is real thick metal. It's designed to protect the pump, so all that can be used. This right here, this is just the part of the evap system. This is the only spot this fuel tank can get air to breathe. So the factory setup, this would go to your filler neck, and it also tee off and go into your charcoal canister in your evap system. The reason this goes to your filler is once you unscrew your cap, your tank can now breathe all that extra air, so when you fill it up, you can actually fill up your tank. Because if it's not a big opening, it takes forever to fill a tank. Because as you push fuel in, that same amount of volume has to come out as airflow. So that's why this is so big. I mean, this is like a 1/2 inch. And then these are just extra fittings for the carbureted tank. I put some marine JB Weld that's fuel safe, so it won't leak out of it. So I learned a lot. Again, if I could do this again, I'd try to get a deal with Boyd's Welding to leave all these extra ports off. That's good. That uses a Dorman fuel sender, which comes in all different ohms range. So I use that one for a Gen 5. So my Gen 5 gauges will work on fuel level. Then get it without baffling, and it would work really nice. Besides programming, which I have down pretty well, but it can be a pain in the butt. Oh, these are the new headlights. These are off Amazon. They're LED headlights, and they work really well. Cool. Well, thanks for watching, and let me know what you think about the video and what you think about the fuel system. Thanks. Bye.